Hi there, another lesson for Year 12 Maths, looking now at the derivative of a function. Now the derivative, I should point out straight away what the derivative means. So here's the derivative. We're looking at the derivative graphs in actual fact, but the first thing you should learn is that the derivative of a graph is really its gradient. I'm going to write that here. Derivative equals gradient. So if I want to know its gradient, I'm really asking for its derivative. It's just a new word that we need for A-level maths. So here, for instance, if we just do here, you can see its gradient is positive. Its gradient is positive because it's going up. It's an increasing function. So the gradient is greater than 0, therefore its derivative is greater than 0 in that little interval. So just get used to this word, derivative. Derivative graphs then. So I'm just highlighting again, the derivative of a graph is its gradient. Bear that in mind. When the curve is increasing, here's an example of that. So for instance, from there onwards, and in other places, but that section of the graph is definitely increasing. And we say its gradient is positive. When the curve is decreasing, it's negative. So let's find that. Alright, so in between there and there, you can see from here down to here, it is decreasing. And at that point, the gradient is negative, decreasing. And then there are three areas we need to know. Increasing, decreasing, but you get some points in between. And these are often called stationary values or stationary points or even turning points. So this is a stationary point. And they're stationary points basically because the gradient is 0. So we've got two that do that. I think there and there. So look out for this. When the gradient is 0, it's a stationary point. So, you know, we'll come across that more and more and more. Now I want to do an example of a graph that you saw at GCSE. This is actually the graph of y equals sine of x. And what I'm going to do, now this is in degrees. Now that kind of matters because you were meant to know at GCSE, for instance, that if you typed into your calculator the sine of 0, you get 0. And there it is, the sine of 0 is 0. If you typed in the sine of 90, you get 1. And that's why this here at 90 goes up to its maximum point. That's a stationary point, actually. You can see it. Sine of 180 is meant to be 0 again. There it is. Sine of 270 is meant to go down to minus 1. And you can see 270, I think, is there. And finally, it gets back to 360. And when you get back to 360, you're back to 0 again. And that's actually one cycle of this graph. It goes... And actually, it keeps on doing that forever and ever. It never ever stops. Now that's the sine graph. Now what I'm interested in is how steep this graph is. So here, it's got a steepness to this graph. And I don't really know what the steepness is. And the reason why I say that is because this is in degrees actually. I don't actually like it in degrees. But later on we're going to draw this in a new type of angle. But for now it's fine. All I'm saying is here, you can see it's going upwards. And because it's going upwards, if I draw its derivative graph, I'm going to write over here, derivative graph. At 0, you can see it's positive. Now, I don't know what the value of this is. I'm making this up. I'm going to say it's 2. Its steepness, I can't really do in degrees. So I'm not actually that fussed. All I care about, I'm going to get rid of all these numbers and not care about the numbers at all. All I care about is it's positive. It's somehow positive. It's up there somehow. And what you'll notice here, by the time it gets to this point, we're on the turning point. Its gradient here is actually 0. So having been positive here, by the time we get to 90 degrees here, it's got a gradient of 0. So therefore you can see I've drawn the graph, and I think it's going down. For instance here, it is still positive, but you can see it's less positive than it was, and certainly here it's less positive again. So we're going to have to try to reflect that somehow. It's getting less positive like that. I don't know exactly how we'll do that, but And then after that, you see, it starts to go down this graph. And as it's going down, therefore, it's got a negative gradient. So, again, by the time it gets to 180, it seems to be at its steepest it can possibly be. And then it starts coming back. So, what I'd think about that is, I don't know exactly how steep it is, but by the time it gets to 180, it's as steep as it can be. So I'm just going to mark that down there. Somehow it gets there, and whilst it's here, it's pretty steep, but to start with, it's not that steep at all. So initially, it's, you know, not that steep, a low amount, and then bit by bit, it kind of does that. Once it's to there, then it starts tailing off again. It's not as steep here. It's still downward. It's still negative. So it starts tailing off, and by the time it gets to 270, I think it's on 0 again. Because you can see it's a turning point. It's got a 0 gradient here. So I'm not interested in what the y value is. I'm interested about its flatness at the bottom. And actually then it starts going up again. You can see this is increasing. It's going upwards, it's going upwards, it's going upwards. So again, by the time it gets to 360, there, I'm going to mark it there again. And what I'm kind of hinting at is I end up, I'm not exactly sure what it is, but I'm ending up with that graph, whereby this graph which I initially had is actually y equals sine x, but this graph which I'm going to end up with is not y equals sine x, it's some other graph. You might recognize that graph, or at least something similar to it. So that's what we've got to do. So let's have a go at this one. Sketching this function. Now notice on this one I'm not telling you what the function is at all, it's just a graph. So I want to find on this graph the where it is steep, where it is not steep at all, where it's going up, where it's going down, where it is flat. By flat is one of those stationary points. I think there's a stationary point. I think here's a stationary point. I think in total there are 2 stationary points. Look, I'm so tempted just to draw a set of axes. It's not my best set of axes, but you get the idea. So on this graph, at this point here, I've got no value for it, but about there and about there I've got some stationary points. Now where I get stationary points, it's got no gradient at all. You can see it going flat straight across. It's going flat straight across. And therefore its gradient is at 0. And therefore if I draw a derivative graph, and again this is meant to be a derivative graph, I've got to put it at 0. Now interestingly, to the right of this one, let's start here. So to the right of this one it's positive. It's going up, it's going up. I know it doesn't look as if it's positive, but it's going up there. It's going up there, it's going up. In fact, it's getting steeper and up as well. So I'm just thinking to myself, it starts off quite low, but then it definitely gets steeper and steeper. Now, interestingly over here, again, it looks as if it's underneath the axis. Indeed, it is underneath the axis, but the actual graph is going up, going up, going up. So this has got a positive gradient. It's very, very steep initially. And then as I get closer to this turning point, it's almost there. It's still going upwards, but not as up as much. You can see its gradient is not as steep. So I actually think it looks something like that. Now what about in between the 2 points? In between it's actually going downwards. It's going downwards. It's going downwards. So I think it's doing that. It's negative gradient. And I think that's the gradient graph. Bit of a surprise really that you've got some positive bits over here where it's actually on the graph, it's underneath. Yeah, that's what I've done. I don't know why it stops there, but you get the idea, it carries on going. Here's another example. It says you're given the derivative of a function. That's all right, I see what it means now. So what it's basically saying, this is the derivative graph. And it actually wants me to sketch a possible graph of the original function. Notice it says a possible graph. There's more than one possibility, but derivative graph. So let's try and work backwards, and which I think is what we need to do, and draw the original y graph, y and x. Now, where it's 0, now just be aware of this. This is the gradient is 0. This is the gradient is 0. This is the gradient is 0. So at these 3 points, we have turning points, we have stationary points, because the gradient is 0. Where it goes above the line, that means the graph is going up. So we've got a stationary point. I don't know exactly where it is. This is why it says possible. So it could quite easily be the case that my final graph I get is different from the original graph that they was intending. So that's my get out clause here. But all I would say is here it is positive, and then it goes, it's maximum positive there, and it starts leveling off again. So what I would say is it starts at being, well, it starts initially. I've got this, I don't know exactly what's going on, but I'm going to put a dot here, and this I'm going to say is my turning point for here. I know it's a turning point, a stationary point, because its gradient is 0. And I've got again, it goes, it's positive, it's positive, it's positive. All that area there, it's basically, it's going upwards. It's got a positive gradient, so it's got some, but then somehow it's got this other turning point here, this other stationary point is 0 again there, and then a bit later, now it's going down, and so where it's going down, it must be kind of going down like this in some way, and then at some point over here it is got a turning point again. I don't know really what's going on. I could easily have drawn all those points there, there and there. I think it goes up and then down. How it does it. Now what happens on this side? Now this is going, the derivative graph is going up, but in actual fact it's all on the negative side. So the actual original graph must be coming down. I think it's got to be coming down. Now again, where you draw that is up to you. And then here it is going upwards. You can see it's definitely going upwards. It's got a positive gradient. It's getting more and more steep. So again, I think it's something like that, or something like that. My graph could quite easily be like that, or I could draw it further up, and it would make no difference at all. I think it's something like that, and I don't know. Again, notice on this one I've drawn it slightly higher there than there, but on this one I drew it the other way around. I don't think I can really see. Let's see what the actual answer is. In fact, it's very similar to this. But it could have been either. There's no way of knowing really which was the original graph, and we'll come back to that later on. This comes back to this idea that you end up getting what's called a family of possible curves. This family of possible curves, which any one of which would be good enough. Notice they are related though. That one you can see vaguely looks like that one, but it could easily say, well, it's just a translation of that one. Some questions for us to think about, and maybe I'll leave you to just finish these off after I've started you off. Decide whether these statements are always true, sometimes true, or always false. So the first statement says, at a point where the derivative, remember the derivative really means gradient, at a point where the derivative is positive, the original function is also positive. And I think that might be true, but not always true. So I'm just going to make up a function. So here you can see that it's slightly going up. The gradient here is positive. Gradient is greater than 0, but the y value, you can see it's underneath the line. The y value is less than 0. So I think that sometimes it could be right. Here, both of them would be right. Can be above and be positive. So I think this first one I would say is sometimes. What does B say? If the original function is negative, I'll take that point there, then the derivative is always also negative. Well, it might be. There, for instance, it is. It's going down at that point, it's under. But here it's going up and it's under. So I think, again, this is sometimes true, but not always. I want you to go through those and just get your head around and just decide whether you think it's sometimes true, always true, or always false. And that presumably is a mixture of all. So pause the video now. I'll then start it up again and you can check your answers. Okay, I think you've probably paused it and done the questions by now. If you haven't, quickly do please. Here are my answers. Well, I say mine. I haven't looked at them either. So sometimes, sometimes, always, sometimes, sometimes, sometimes. All right, I hope you didn't say never then on any of them. Those were the questions we're going to do in class, exercise 13a, and hopefully that will enable us to do them. All the best.